Okay, so let's have the guided practice problem 1. So read it on the PowerPoint or on Canvas. So we're going to answer it here. So for the given, all right, so we have velocity, which is 0 because it's stated there that it's starting from rest. Okay, then of course we have g, which is 9.8 meters per second squared. So what are the required? So required are, we have 6 required, so let's set those required as v1, v2, and v3. Okay, then for the displacement, we have delta y sub 1, we have delta y sub 2, and then delta y sub 3. Okay, so there. So if you're going to draw it, it's fine. So you can draw the leaning tower of Pisa, let's say somewhere here on your paper. So let's say it's leaning there. So that's something here. Okay, so if you drop something, so something like that, so we're going to measure this 6. So for the equation we have, so look at what do you call this, the things that you need. So you have, first let's focus on this. Alright, don't focus on this one yet, so let's focus on this first. So we have v, g, and final velocity. So for the general oh yeah, I forgot, we have given time. So we have our t sub 1 at 15 seconds, sorry. We have t sub 2 at 30 seconds, right, at 20 seconds. Then we have t sub 3 at 30 seconds. Okay, so okay, let's repeat the process. So let's cover this one first. So what we're going to have are v sub 0, g, v sub 1, and t. So the equation for that is, it's too obvious, so that would be v is equal to v sub 0 plus g delta t. Okay, then we're just going to substitute each one of the time and of course the rest to obtain the values of v1, v2, and v3. So that's well too easy. So this is the first equation. For the other one, we can use, actually you can use equation 3 or equation 4. Okay, so for equation 3, if you're going to use that, so you have delta y is equal to g delta t squared over 2. So you're not going to have plus v sub 0 delta t, since v sub 0 is equal to 0, so you're going to eliminate that. Okay, so for the other one, if you fancy to use the fourth equation, so that would be what would that be? So that would be v squared is equal to, so v sub 0 squared is cancelled because the value is already 0, so that's 2g delta y. Okay, since we need delta y, so you're going to divide both sides by 2g. Correct? So the form of this would become delta y is equal to v squared over 2g. Right, so this would be the equations that you can use. So this one, you can use it to obtain the values of y. So we're going to try both. Okay, I'm just going to solve for the 15 seconds because I think you can get the hang of it, because it's just repeating the process. So you do t sub 2 and t sub 3, Alright? Just follow the step and you're going to understand it. So for the solution, let's do V1. Okay? So V1, we have, that's V1. So V1 is 0 plus G is 9.82 meters per second squared times 15 seconds. So you're going to cancel the time. So you're going to have meter per second. Okay? So I think that's easy enough. So V sub 1 is 9.8 times 15. So what's the answer to that? Okay, so let's do that. 9.8 times 15. Can you see it? Right there. So that's 147. Okay. 147. What's the unit? Meters per second. Okay, so we have V1. So these are the answers. You see, it's too easy. If you're going to do it, always show your complete solution. But I'm going to write the value of V2 and V3 so you can check your answers as well. So for 20, the answer is 196 meters per second. Okay, then for V3, so this is 294 meters per second. So these are your answers. Always box the final answer so I could easily distinguish the final answer, then trace back the step that you did. Okay, so the important thing here is show the cancellation of units. Alright, I always want to see that. Now for the displacement, okay, I'm going to do one for each of these equation. Then you can do delta y sub 2 and delta y sub 3. Okay, so I'm going to do delta y sub 1. Alright, so I'm going to use this equation first. So we have 9.8 meters per second squared times 15 seconds to be squared divided by 2. Correct? So what's the answer to that? Okay. You're going to notice you can cancel the seconds, but don't forget to square 15. You might forget that. Okay, so you're going to have a unit of meters, which is the one that we're looking for. So let's put that here. So 9.8, let's make that a fraction. 9.8 times 15. Can you see it? Here. 9.8 times 15 divided by 2. So that's 73.5. Okay, so that's I forgot to square. Sorry. Don't forget to square. Okay, so this is 15 squared. There. Alright. So this equation, this is a pesky one because it somehow looks like this. But don't forget to square time. Okay, don't you ever forget to square the time. So here is the correct equation. Let's place this inside the parentheses just to be sure. There. So the answer is there. This is the correct one. 1102.5. Okay, 1102.5. The unit is meters. Okay, so this is using this equation. How about the other one? So delta y sub 1 is, we have this. What's our v sub 1? So we're going to use v sub 1 for, of course, for delta y sub 1. So that's 147 meters per second. This is to be squared. Alright, divided by 2 times 9.8 meter per second squared. Okay, so to show this properly, first square this. Okay, so let's square 147 to be squared. Okay, So this is 21,609. You're going to square the units as well. So meters squared per second squared. Alright, so divided by, you can multiply this now. So this is 16, 9, 18, 19.6 meters per second squared. Correct? Okay, now show the cancellation of units. So cancel the seconds. Then you're going to notice meters squared divided by meters. Of course, the exponent is 2, then this is 1, so that's 2 minus 1. So you're going to have a remaining unit of meters, which is, of course, what we need. Okay, so let's try to divide that. So 21,609 divided by 19.6. There. The answer is the same. Okay, so this proves that the kinematic equations are a very handy tool. Because whatever are the equations that you are going to use, you will always arrive at the same answer. But of course, you have to take note that you must do the correct procedure, alright, when doing that. Before I move to the next problem, I would like to remind that you're going to notice that I used a positive value for G. Because what I've said earlier, always remember that G is moving downward. So if it's moving downward, velocity is speeding up at that direction. So that means G should be positive. So that you would have that idea of speeding up or accelerating. Okay? So let's move to the next guided practice problem. I hope you're going to do V sub 2, V sub 3, delta Y sub 2, and delta Y sub 3 on your own. So you could get the hang of performing the equations. Alright? Alright, so for the third problem, let's write the given. So the given is we have a velocity. So it's thrown vertically with the speed of. So that means it's starting at that speed because that's the speed it's being thrown at. Okay, so that's 25 meters per second. Okay, and then we have a height. So the height is 7 meters. Okay, so the question or the being asked is the velocity that this stone is moving from this height, okay, and then at the same time the time it reached to this height, okay, the time it reached this height. So if you're going to draw it, so let's say you have the stone, okay, which is moving upward. So reaching that maximum, oops, you can't see it. Okay, let's move it a little bit further down. Okay, so here, so reaching that maximum height will mean that the velocity from here is 0 meters per second, correct? Because it will stop at that point. Okay, so that means G moving upward is negative. Okay, so that's what we're going to do. So for the equation, first let's find the final velocity. So we have V sub O, we have delta Y. Of course, don't forget your G, which is 9.8 meter per second squared. Okay, so we have 4. So look at your table or guide for the equations, and you're going to see that the most appropriate equation to use will be this one. Correct? Okay, now remember that our object is moving up. It means at that certain height, the velocity that it's going to hit must be 0. Okay, if it's going to reach this one, so it must be slowing down. Alright, so you have to change the sign to negative to accommodate the g is negative when the object is moving up. Okay, so after knowing that, we can now solve for the first required, which is v. So we have v squared is equal to, so what's our v sub 0? So that's 25 meters per second to be squared minus 2 times 9.8 meters per second squared times, what's our delta y? 7. Okay, so there. For good measure, always remember that you have to, place more parentheses, because your calculator might do MDAS instead of PEMDAS, and it might operate what they call this, in accordance to the arrangement of the equation, and you don't want that. Okay, so we want to follow, of course, parentheses first and then multiplication, etc., etc. Okay, so the first thing you're going to do here is, of course, square this. So what's 25 squared? 625, correct? Okay, so 625 meters, of course, meters squared per second squared, so that would be squared. Alright, then minus, so what's the value of this? Let's place that on our calculator. So that's 2.98, oops, 2 times 9.8 times 7. So what's the answer to that? 137.2. Okay, so what's your unit? So you're going to notice m times m, because this is m over 1, right? So that's m times m, that's meter squared, then second squared times 1 is second squared. And aha, you have the same units, which is what you want, because the operation is subtraction. Alright, so let's perform this one. So this would be v squared is equal to 625 minus, okay, the previous answer. So what's the answer to that? Here, can you see it? 487.8. Okay, 487.8 meters squared per second squared. Of course, what we need is final velocity, or v, not v squared. So of course you have to find the square root of both sides. So cancel the squares. Okay, so that would be v is equal to, okay, so square root of answer there. So what's the answer? 22.086. Okay, 22.086. I want to preserve this what do you call this, decimal point, because we have another required. Okay, so just for good measures. So of course we have obtained the square root of the units as well. So we have meters per second. So as you're going to see, it's lower than your initial speed because it's slowing down. You get that? Okay, so that means if you're going to translate this answer to a statement form, upon reaching 7 meters, the stone is moving at a velocity of 22.086 meters per second, which makes sense because it must slow down. Okay, so for the time, let's do that. So oh wait, we don't have the equation yet. So for the equation, I'm just going to write it here. Okay, what can we use? We can use the first one, right? So that's v is equal to v sub 0 plus g delta t, and of course it's moving up again, right? So we want to change this to a negative sign. Okay, then let's do some math magic. So separated by subtraction, so you can move this to the other side. So that's v minus v sub 0 is equal to negative g delta t, correct? Then divide both sides by negative g to obtain what we need, which is time. Okay, so your equation would be delta t, See, delta t is equal to v minus v sub 0 divided by negative g. Alright, so for the solution, you have delta t is equal to, what's our v? 22.086 meters per second. Okay, minus, what's our v sub 0? 25, correct? Meters per second, divided by negative 9.8 meter per second squared. So you can operate first on the numerator. Okay, so let's do that. So that's 22.086 minus 25. So that's negative 2.914. Negative 2.914. So the unit is meter per second, of course, divided by negative 9.8 meter per second squared. So you're going to notice they are both negative, so cancel that. And then meters, seconds, you're just gonna need to cancel this one and this one. Since this is on the denominator, it's going to be transferred on the numerator after doing a reciprocal, because the operation here is division. Okay, so let's do that. So 2.914 divided by 9.8. So what's our answer here? Okay, so that's 0.297 or 0.3. Okay, so that's our answer is 0.297 or, oops, this is seconds, or 0. So rounding off to the hundreds place. So this is 9, of course, then this is round off, so 0.3. So either of this is correct. Okay, so for the second case, remember that one of the scenario might be the object is moving up. Okay, so since we're dealing about free falling body, so no air resistance, no, for example, rocket problems where you have a fuel pushing the rocket faster. So that counters the effects of gravity, right? So we don't want that. We just, of course, we want the simpler things in life first, because we're just starting. All right, so for the next practice problem, let's do that. Okay, thank you.